So we actually change the position of this. So let me see. Seems good to me. Okay, so I just want to give you some examples. The first one, let me remind you, we talked about the subtraction of vectors. Yes, do you remember? Now let me give you a very simple example. So assume that I have these vectors. I have three vectors I want you to construct. So construct the vector A minus B minus C for the following vectors. Okay, so good. So the vectors are these. So let me keep one of them horizontal, A, and let me, for example, give you this vector B, and then let me draw another one here, C, for example. Now I want you to construct A minus B minus C. Okay, so hopefully you remember this, that the subtraction of vectors was defined through the addition. So this means A plus minus B plus minus C. Agree? So this means that if I want to construct this vector, first I need to draw the opposite, the negative of B. So which of course you know what that is. So negative of B, for example, if I want, I can draw it from here. This is called negative B. Parallel to that one with the same length and in the opposite direction, that's negative B. And what is negative C? This is negative C. Yes, so this is negative C. Then, instead of thinking about differences of vectors, I can think about adding vectors, yes? But so forget about the names. You have a black arrow here and two blue arrows, you want to add them. Don't think about subtraction at all. So what I need to do, I need to parallel transport this and put it from the final point of this one. So this becomes something like this. If that is, so that you don't need to write the name. So that is parallel transport of B. And then I need to go to parallel transport, sorry, that was the parallel transport of minus B. And then I have to parallel transport minus C from the tip of the second vector, something like this. Yes? And then there is an initial point and there is a final point. So you need to connect these two. Yes? And then put the arrow, put the tip of the arrow here. So this vector is A plus minus B plus minus C, but it means A minus B minus C. So this vector is A minus B minus C. Yeah, is that okay? Understandable? Okay, let me give you another example. Without drawing any figures, simplify each one. We are supposed to simplify very simple ones. So AB, vector AB minus vector CB. Now let me write the second one here. Number 2, AC, vector AC minus vector BC minus vector DB. But let me change my color to write the answer in front of it. I think you know how to do it, yes? What should I do? Yes, Abdullah?
You can change CB to BC, but you need to change the
Sign.
sign in front of it.
Exactly. So it becomes equal to, I keep AB as it is. This is an important rule to remember. You're allowed, if you want to, you're allowed to interchange these two letters, but the price that you need to pay is to change the sign from negative to positive or from positive to negative. So this becomes plus BC. And I think the motivation is clear why this is useful if you remember Charles' rule, yes? Because now I am adding the vectors and the letters in between are exactly the same. So I can use the Charles rule. I don't need to draw any figures, yes? So what happens, it becomes, I can, in my head, I can think in this way. I can eliminate these common letters, and then what is left, A and C. So if you don't believe it, you can just draw the picture and see that this is the case. Let me remind you about if I want to draw a figure. So if I want to draw a figure, let us see how it works. So here I have 3 points involved. Capital A, capital B, capital C. So let me write, so just randomly choose 3 points here. It doesn't matter. So A, B, C, there are 3 random points. And then AB starts from A, ends at B. So it becomes AB. And then CB starts from C and then goes to B. But if I want to subtract 2 vectors, what I need to do, I need to find the opposite of CB. The opposite of CB is the same vector, but in the other direction, yes? Yeah, so that is mine, this black vector here. It is exactly lying on it. You can parallel transport it, it doesn't matter, but let me keep it here. That vector that you see is minus CB. Or of course, it is clear that its name is BC, yes? And then you add these 2 vectors, then it is clear that you get vector AC. But you see, you need to spend some time to draw pictures, to try to analyze the picture, to understand this. Whenever it can happen with the short word, it's much easier. Okay, let me just do this one. What is the answer to this? How do you think about this problem? D. Let us see. How did you say that? Yes, you are saying probably saying that I do the same rule. Yes, I change these 2, and the price that I have to pay is to change this negative sign to positive, so it becomes CB, and I can do the same thing here, so it becomes BD. Yes, and then I can apply the Charles rule in 2 places. Yes, between these 2, it becomes AB, and when I get the answer, so let me write it. It becomes AB, the first 2. This becomes AB, and then I have another BD at the end. Again, I can apply the same rule. This becomes AD. So yes, you are right. Thank you. This is AD. There are some questions in the book even like this. So example. Write a vector equation for each figure. Write a vector equation or relation, it doesn't matter. And write a vector equation. Equation means equality, which is always correct. So let me write, equation is not a good, let me write identity. Identity means something that is always true. Write a vector identity for each figure. So for example, one of the figures that I have drawn is this one. So I have a vector A here, and then I have a vector C here, a smaller vector B here, and then D from here to there, yes. So this is also very a standard vector question. I want you to understand this. If you don't know the rule of thumb for this question, you might start doing some trial and error, but it is not needed. Do you have any idea yourself before I give you some kind of hint? Whenever you have a closed polygon, immediately you can write a vector identity there. I'm just emphasizing closed polygon. So that's a closed quadrilateral, yes? It contains 4 sides. It might be a pentagon, it might be a hexagon, but it doesn't matter. As soon as you have a polygon, and it doesn't matter how do you write the vectors on each edges, you can point it in this direction or in that direction. There is a simple way to write an identity. And don't get confused at all. So the idea of displacement is very, very helpful here. Yes?
So are we supposed to find like some vectors equal to another, or what is?
No, you need to write a vector identity. What does it mean? It needs to be an expression containing vectors and containing the equality sign, which is always true based on this picture. That is the meaning of this question.
Well, could I say something you could start off with?
Yes.
Could name like every like edge or point like something, and then instead of writing C, vector C, you could write vector.
You can, but you don't need to.
Okay.
Yeah. I just want to use these letters that I have put in the figure itself, and then use them to write equality, which is always guaranteed to be true if this picture is the picture. Yes.
Like the magnitude of the vector A plus vector C plus vector C is all of them together is the magnitude of all these together.
No, the magnitudes. Be careful again. You were completely on the right track. You made a mess at the end. So the magnitudes. Be careful. I have to repeat it. If you want, I can swear. Okay, this is not correct. A plus B. The magnitude is not equal to the magnitude of something like this. Of course, you can say inequality, but inequality is not identity. Identity means equality. Okay, so if you are saying something like this. So be careful. The norm, the magnitude of the sum is in general not equal. Yes, that's the grammatic correct way of saying, yes. It shouldn't be equal to it is not equal to the magnitude of the first one plus the magnitude of the second. Okay, but what's the idea of displacement? When you go back home to your bed, you wake up in bed and you go back to bed. So what's your displacement?
0.
0. So that idea will help. That's the same situation. So assume that this is your bed. You start, I don't know, go to toilet and then go to school and then go to the restaurant and then you go back to the bed. So that displacement should be 0. Yes? But I start from my bed, go to the toilet, for example. So I follow exactly this vector.
Yeah.
Then I go to school. I follow exactly this vector. But then when I go to restaurant, I am not following exactly this vector. Yes?
Plus negative C.
Plus
vector.
negative C, exactly. So then plus negative C, I am here. Then I am done and I go to bed. So what is this one then?
Plus negative A.
Plus negative A. What is the total displacement now?
0 vector.
0 vector. Thank you. That is very important. Not
You're
0 vector. But then I don't write this. If you write this, that's okay. But in mathematics, when you simplify, you can simplify. Nobody writes plus minus because there is a better name, just minus. Yes. So we write B plus D minus C minus A equals to vector 0. And I don't know, myself prefer to move these. I don't write it. I want to be always positive. So I will take these up to make it positive. Yes? So you should be optimistic always. Yes? So P plus D, that's of course, if you write this in the exam, that's totally right. Because it is true and it is vector, involves the vectors, and this is equality. So that's a vector identity. So I myself prefer to don't look at the negative aspects of life, yes? So I will take them to the right-hand side. So B plus D is equal to A plus. Is that clear? Yeah, as simple as that. So this is what I want you to write, for example, in this exam, to this picture. So let me draw a pentagon for you, and you can do it yourself, and then we go to the, yeah, I have to hurry up. So, yeah, you can just work on it yourself. P, Q, and then R is in this direction. And then you have vector S. And then finally you have also this vector. Vector is 1, 2, 3, 4, 5. That's a pentagon, okay? So you want to write the same, you want to do the same thing. But now I think everything is simple for you. It doesn't matter where you start, by the way. You need to start from a point that you like, just go one full round and come back to the same point, and then add all those vectors, okay? That should be 0. The 0 vector.
We have this zero. For the displacement.
I want to save time so you can work on it. I want to write 2 examples and then we are done, okay? This example is important. It's a higher level problem. So let me, it is also sometimes in the book and it's in the national test, but of course we don't have any national tests this year, but these questions are typical. Consider the following figure and write each given vector. This is a terminology I use a lot. I don't know. You could put another picture of me and write in terms of this time instead of my convection. Because this, I really use it so much. Okay? So write each given vector in terms of R, vector S, and vector T. So the picture that I give to you is this one. Some of them are just normal lines. Some of them have been emphasized to be vectors. But from any line, you can make up 2 vectors in each direction that you like. So, and then for that reason, I am also giving you these names, OT, S, and R. I hope that you are not confusing this with trapezoid. It might be a trapezoid, but there is no necessity for that. So let me make it a little bit bigger so that you are not confused that this is 100% a trapezoid. So this is S, and then this is capital S. Okay, so I will write this number 1, RS. Number 2, of course, this is simple if you can solve the first one, SR. Number 3, ST. Okay. By the way, sorry, this is also vector T. The small s as a vector, capital S as a point, capital R, capital O, capital T. Okay, let me go back and ask you. I think this is simple. Everybody can answer this one. Yes? Any volunteer to answer this one? Yes?
Let's just start from there, exactly. So T vector.
So you go in this direction?
Yes. plus S vector
Yes.
plus R vector
Yes.
minus Q vector
Yes.
minus P vector equals 0 vector.
0 vector.
Or,
To be optimistic in life.
exactly, T
Yes.
plus S plus R equals Q plus P.
Q plus P. Yeah, that's it. So it's very simple now. I think everyone can understand that. But this is a little bit higher level question, and some of them are not that trivial. If I want to make the picture complicated, even myself can get confused at the end. Okay. So, first of all, I want you to understand these three words together, two prepositions and one word. So, in terms of what does it mean? So when I say write each one of these vectors in terms of R, S, and T, it means write an equality for me so that if I give you these vectors, you put them in that equality and I get my answer for this. This is the meaning of writing in terms of something. For example, when I say Z is equal to X plus Y, I can claim that Z is written in terms of X and Y. Because if you give me X and Y, I can immediately find Z. Yes? X is also written in terms of X and Y? Not exactly right now, but if I want to write X in terms of Z and Y, you remember we had it before. We make X the subject, I move Y to the right-hand side, it becomes negative. So this means X is written in terms of Z and Y. So this is the meaning of writing some quantity in terms of other quantities. So it means that write that quantity on the left, equal, and then write something on the right, which is only related to those variables which is given in the problem. So I don't think it is hard at all for you, okay? So can you write RS, this vector RS? Where is the RS, by the way? It's from here to here. So it means that by reading the first part, I understand that I have to put an arrow here because I am talking about vector RS. So this vector, how do you write it in terms of R, S, and T? You don't need necessarily to use all of them, but what you write should be something related to these three vectors at all. So what is that one? What is RS? For example, do you think if I add R to S, if I add this vector to this vector, do you think it will give me that one? Yes or no?
Confused.
Yeah, it's going to be confusing. Yes, so you need to be very good in understanding how to draw the pictures. But I told you two things. Do you remember? So especially for these problems, even though you can always add vectors with the standard method, but I also talked about parallelogram method. It's better to have it in the back of your head sometimes. And then for subtraction, I also told you something which was very important. Let me repeat it again. If I have two vectors here in this form, so you see, if I have these vectors in this form, this is the standard for addition. The second one is being drawn from the tip of the first one. If that is happening, addition is the simplest possible thing. You just connect these 2 points, and then you put this tip of the arrow here. This becomes vector A plus B. Okay? But now, if I do this one, if I ask you to add A to B here, you might say that, okay, I only learned this method. Yeah, that's correct if you want to add, because you can say that I parallel transport this one and draw it from here and then add to it. But I want you to at least, even though I myself most of the time use this parallel transport method, but it doesn't mean that I don't need to learn about parallelogram method. Okay, you have to learn that. So if two vectors are being drawn from the same point, another method is also useful for adding A to B. Do you remember? We need to complete the parallelogram. How? By drawing a line parallel to this one and drawing a line from here parallel to the other one. Whenever they intersect, I connect these two. The only thing that you need to remember is to put the tip of the arrow here. This becomes another way of visualizing the A plus B vector. Okay, this is one way. And then, of course, if I ask you to subtract these two vectors, you know how to do that. You can, for example, find minus B and then add these two together. But whenever they have been drawn from the same point, there is a simpler way to do that. Even if you do this, that's not wrong. But what I'm trying to say, just connect these 2 points together. Okay? And then if you want to draw A minus B, you need to put the tip of the arrow for the positive one. The positive one is A, so I put the tip of the arrow here, and this blue vector is simply A minus B without finding the opposite one, without parallel transporting at all. Is that understandable? It means that if you, let me just do it for you. Assume that I don't want to use this. How should I do that? First, I need to find the opposite of B. For example, this is opposite of B. The same length here, so I put it here, the same length. But it should be in the opposite direction. If I ask you what is this, this is minus B. Okay? And then I parallel transport this from here. It becomes this. And then I add these 2 arrows using the standard method. Oops. But you see, if I draw it very exactly, these 2 vectors are parallel, pointing to the same direction and of the same size. So if this is A minus B, that simple one is also A minus B. Is that understandable? So remember these 2 pictures. Even though you don't need to know these methods if you want to draw, but because you also need to be able to solve these kinds of problems, it is better to have these 2 pictures in mind. So let me just quickly repeat. If I have 2 vectors drawn from the same points, if I want to subtract, if I want to construct this, it is very simple. Just connect the ends. A is positive, put arrow here. This becomes A minus B. Yes? And then if I ask you to add them, even though you can parallel transport them, but another way to do this is to complete the parallelogram and then draw this diagonal. This becomes A plus B. Yes? This is important to know. Okay, now you see this is happening. You see, I have 2 vectors, R and S, are being drawn from the same point. And the final points are being connected. And the direction is towards S. So now can you tell me what is RS? So let me write with blue. What is RS? What is that? Again, I have 2 vectors drawn from the same point, R and S. The tips of the vectors are being connected, and the tip of the arrow is on this S. Yes?
Negative R plus S.
So I would write negative R, yes, S minus R. Yes. This is S minus R. Do you agree? Is that clear? This one is S minus R. Okay, when this is S minus R, you don't need to even look at the figure. What is SR? SR is the negative of RS. So you multiply this by a negative. The first one becomes negative S. The second one becomes positive R. Understandable? Now, what is ST? That's also very simple now. What is ST? ST is this vector. If you want, I can put the arrow, you can see. ST. How can I write this using these 3 vectors? Of course, here I use 2 vectors. Here I'll also use 2 vectors. So what is ST? So you see these 2 vectors are being drawn from the same point. And the final points are being connected by this vector. So it is related to the difference of these 2 vectors, yes? Because I just told you. But which direction is important to write it to? So how should I write it? The order is important. So can you tell me which one minus which one, or which one plus this one will give me ST? Yes?
T minus S.
T minus S, because it is pointing towards T. So you should write T minus S. Okay? I will bring more of these examples in that playlist that I mentioned. Okay, so we can talk. You can, if you are interested, you can go and try that yourself. Okay, one more problem. We are done for today. This is also a very important problem. So, example. Let Q be the midpoint of the side PR of the triangle ORP. Show that OR, vector OR minus vector OQ minus vector PQ is the zero vector. I would think that I will wait for 2 or 3 minutes so that you can give it a try yourself, at least to understand the problem. Then I will solve the problem and we are done. It's exactly 5 minutes, yes? In these kinds of problems, first I will think, is it possible to use the shall rule in a way that at least I can simplify the expression a little bit? If I can find a way for that, first I do that, then I will refer to the picture. But some harder problems are the problems that you cannot just solve the problem only using the shall rule. You have to understand the geometry as well. So I think if I understood it correctly, one part of it can be done using the shall rule with the tricks that you just mentioned in the previous problem. Any ideas? Which part you can done? Which can be done? Yes?
OQ and PQ.
OQ and PQ, not exactly. Unless you motivate me, why? Because I don't see it directly. Because it's very important, first of all. You need to respect the rules, everything. When I can use the shall rule? The shall rule can be used if I am adding two vectors. There is another if. That is the middle, only the middle letters should be the same. Not any letter that you like. For example, if I write AB plus AC, is it the shall rule? No. Even though I am adding, even though I have a letter in common, but that letter in common is on the side, left-hand side. This is the shall rule. If I have BA plus AB, then I can use the shall rule.
But you can't you just switch AB then?
Yes, you can do that.
Yeah.
But you need to do them and then say the shall rule. At least, but this is why I said, Maximilian, can you motivate me? Because I cannot see this is the shall rule. First of all, I have the difference. The second reason is that I see Q here, there. You might say that. Let me ask you. Here, let me keep minus OQ because this is important to understand. Can I replace these sign and write QP with positive sign? Can I do that?
Yeah.
Yes. But is this short rule?
No.
No, because still there is a difference here.
Ah.
Then you should respect everything if you want to use a math rule. Okay? Mathematics doesn't actually bear any tolerances. You have to follow exact rules. If you follow exactly, it will give you exact values, exact statements. But if this is a little bit tilted from what is in the rule, it's not following that. Okay? It's exactly like programming. You can just, this is a very, by the way, how many of you have programming, I don't know. But this is a very good idea to see that you cannot force this damn computer to do something that is very trivial for you, unless you are able to describe exactly what to do. Okay? So that's mathematics. Okay, so this is not the short rule. Okay, but let me just, I want to finish, so let me start doing this. For me, I would do this one. I would write it, so I would start from the left-hand side. I will make this one positive, which becomes what? QO, agree? And then I will keep this one the same because I don't know what to do with that for the time being. This is my left-hand side. But this is in this form, it is not the shall rule, but I can make a shall rule out of it. How? By interchanging these two, it is possible because A plus B is exactly equal to B plus A. So I can write QO plus OR, and then I keep this one the same. I don't know what to do with that. And then this is exactly the short rule. So what's happening? It becomes QR, and then let me keep it in that way. This is better than the starting point, because at least I am dealing with 2 vectors instead of 3 vectors. Here I get a stock. I don't see how to continue. No, we don't get a stock. Do we?
We can.
No, we get a stock because if you want to, this is not the shall right. I had the wrong impression. I can make it positive, but then it becomes what? QR. Sorry, QP. But is this a shall rule or not? No. So QR plus QP, we get a stock. So we have to refer to the picture at this point. Okay? So let me draw the picture for you, and hopefully you immediately realize what's going on. So I have to draw a triangle, call it ORP. So for example, this is my triangle. And when it is not mentioned how type of triangle it is, you draw it as a scale-in triangle. A scale-in means not equilateral, not isosceles, nothing special about that. Okay, so OPR. Okay, so where is Q? Q is the midpoint of the side PR. So Q is somewhere exactly here, of course, when I say somewhere because I cannot see it exactly. So this is Q. I know that Q is exactly in the middle of this side. My problem is to show that this vector plus this vector is equal to the right-hand side, which is 0. But is that trivial now? The vector QP is from here to here. This is vector QP. And this is vector QR. There is no way that I can understand the sum is 0 unless I draw the picture. But now, are you convinced that the sum of these 2 vectors are 0? Yeah. Is 0? Yes. Because why? They are of the same length. Why? Because it is mentioned Q is the midpoint. They are on the same line and pointing in the opposite directions. So these 2 vectors are negative of each other. If these 2 vectors are negative to each other, when I add this, this becomes the 0 vector. And this is the right-hand side. And then I am done. So you need to understand that you can mix, your proof can be a mixture of the shall rule and the picture. Mostly the harder problems, you have to use the picture as well. It's not possible just to the short. Okay, now, sorry, it's 6 minutes now, so I will stop here. You can just study a little bit. You have 25 minutes, okay? And if you have any questions, please let me know. I don't know, I see 7 people online. I don't know how many absence we have. Not 7, yes? Okay, anyway, goodbye.